Oh, now it's going. Okay, cool. All right, so yesterday we talked about law of sines. So we worked a little bit more with law of sines. We practiced it, reviewed it just a little bit, and worked on being able to solve those. Today we're going to continue a little bit farther with our trigonometry, and we're going to talk about law of cosines, which is similar. It looks intimidating. It looks a little bit more intimidating, but it's actually really easy. So we'll talk about law of cosines. We'll have to prove it, which will be a challenge, but we'll get through that together. But to start off with, let's just review law of sines one more time. Law of sines is sine of A divided by A equals sine of B divided by B. So it's angle, sine of an angle divided by its opposite side equals sine of another angle divided by its opposite side. So starting off with, what are we solving for this problem? xy. So I'm going to place a little variable for xy. I'm going to call that t. Make it simple. It's not a letter we haven't used yet. So in order to set up this problem to solve for t, I need to look for opposite sides and angles. Do I have any angle inside there?
18 and 37.
All right, sine of 18 and 37. Or sorry, sine of 37 and 18. It's always sine of an angle divided by its side. Anything else? 21 and t. So sine 21 an angle and its opposite side of t. I need to make sure t is in that formula because if I don't have t, I'm not solving for anything. What's the point? So good. From here, in order to solve, we would just have to take the sine of 37, sine of 29. We're going to get a decimal for both those. I don't know what those numbers are. And then we just have to cross multiply and divide. We won't actually go through solving it, but from there, just finding those decimals, cross multiplying, dividing, and we're good to go. And that should give us t. Once again, another nice thing to check is if this side length is 18 and this side length is 230,364, probably got a wrong answer. So always make sure those side lengths should match up. One's getting like crazy large numbers or crazy small numbers. It's probably not the right size. So that probably means we messed up somewhere. So always go back and check, compare it with those other side lengths you have, just to make sure they should match up. Right. Questions about law of sines before we move on for today? All right. So once again today, we're going to talk about the law of cosine. The law of cosine, it's like law of sine. It can be used on any type of triangle. It doesn't have to be a right triangle like we were restricted to before we talked about this stuff. It looks pretty intimidating. A squared equals b squared plus c squared minus 2bc cosine of a. It's a lot. Luckily, that will be given to you. You do not have to have that memorized. Just like law of sines, you won't have to have that memorized. This stuff will be given to you. We just need to know what it means. So what this represents is we use law of cosine when you're solving for a missing angle. So let's say, oh, sorry, not missing angle, missing side. I'm sorry. So let's say angle A or side length A over here. We don't know what that is. It's a mystery. We need to solve for A. As long as we are given those other two sides, B and C, and as long as we know angle A, the opposite angle of that side length, we can use law of cosines. So B represents one of those side lengths, C represents another one of those side lengths, and A will always be the opposite side. As long as you have those three pieces of information, that angle and those two opposites, or those two other sides, then you can solve for that missing side. And that's what we use law of cosines. So you have this is 33 and this is 47. You can plug those in. It doesn't matter which one is B and which one is C. You can flip-flop it into the equation and it will still be right. It doesn't change whether B comes first or C comes first. And you just have to remember that A just means the opposite if you're missing something. And you're good to go. Questions about the setup of law of cosines? Alright. So law of cosines is pretty easy to use. We'll look at that in a moment. But before we can use law of cosines, we have to be able to prove it. Yeah. So it's kind of difficult proving it. We have all the skills. We know all the steps between algebra 1 and geometry. We know how to do this. We can do it. But it will take a moment. It'll take a little bit of work. We'll have to think about it. But once we think about it, we'll take a little mind break. We'll rest up for a moment, and then we'll talk about actually how to do it. So, gear up. Hang with me. We're going to get through this together. we're going to prove law of cosines. And once we prove it, we're done. We want to prove it ever again. So, starting with this triangle over here, this nice little lovely triangle, we have to end up with this funky Shishkabab matrix. So this is our goal. Starting with that triangle, we want to end up with this equation. Yeah, it's scary. Now the thing is, we're going to need cosine of A in there eventually. But in order to use cosine, sine, tangent, we have to have right triangles. That's not a right triangle. So we're going to have to turn that thing into a right triangle now.
Split C down.
Okay, so we can drop a perpendicular line from C down to that side line C. It's not going to cut it directly in half, but we'll get 6 right angles from here. I sort of made some extra lines on here, so I'm going to label it. I'm going to give them some measurements. I'm going to call this distance from the top of my triangle to the bottom. That's going to be my height. I'm going to call it H. H is just some measurement. I don't know what it is. It could be 37. It could be 2. I don't know. We'll find out. We won't find out, but it doesn't matter. It's just some number. We just don't know what it is. This distance from A to that point, I'm going to call this distance X. Once again, just a measurement. I don't know. It could be 37. It could be 3. Doesn't matter. And then this last measurement over here, I'm going to call this C minus X. The reason I'm calling it C minus X is because if you look at this entire length of this line right here, this whole bottom line is C. So we think about it, in order to actually calculate this, if you knew what X was, and you knew what C was, in order to figure this out, you would just take this whole length minus this piece to give you what's left over. So if you take the whole length of C minus X, we're taking X away, all we're left with is C minus X. And so that's what we're going to call this perpendicular C. Once again, it's just a measurement, it's just a number. We just don't know what the number is. Are we okay with that so far? Now, I need to start getting this and this. I'm going to start with A squared. Start by working and just getting A squared on the board. I have A. A is part of my right triangle over here. My right side right triangle. What side of my right triangle is A? It's our hypotenuse. This is our hypotenuse. That's helpful. Right. Build in the height. Now, if I had C minus X, if I knew what this number was, if I knew what H was, would I be able to solve for A? How? Like, we can use Pythagorean theorem. Our A squared plus B squared equals C squared. But if we actually filled in these numbers, C is our hypotenuse. So C would be A squared. H and C minus X, those are your two other letters. Those are going to be our A squared and our B squared. So A squared would really be H squared, and C minus X would be your B squared. Once again, these are just numbers. H squared and C minus X are just numbers. I'm just inputting them in for our A and B from our Pythagorean theorem. We're just inputting these variables in. We don't know what they are, but that's okay. So are we okay with this so far? We have A squared, and we have a C that is being squared, but it's C minus X squared. So we're getting close. We got some parts in here. We're getting close. On our way. Now, C squared, or C minus X squared, I'm going to split this apart. Rather than having it C minus X squared, I'm going to write it as C minus X times C minus X. And the reason I can do that is if we think about the definition of squaring, squaring is just taking a number and multiplying it by itself. So 5 squared is just 5 times 5. So C minus X squared is just the number of C minus X times the number of C minus X. Are we okay with that so far? Okay. Now, backtracking a little bit, backtracking all the way to algebra 1. We talked about FOIL. So FOIL was when we had two binomials like this that were multiplying together. And what FOIL stood for was first, outer, inner, last. So we multiply those first two letters. Multiply those last letters. multiply the inside letters and then the outside. They're the last ones. The first letter outside inside. This gave us our quadratics that we had dealing with a lot of last year. Typically it was like x plus 3 and like x minus 2, and then we FOIL those together and we get a quadratic as our answer. We're still doing it, we're just using some variables. It's just a little bit uglier, but it's nothing we can't do. So we look at this. C times C is C squared. C times negative x is just two variables, negative cx. Negative x times c is the same thing, negative c and x. And then negative x times negative x gives us a positive x squared. The negative times the negative gives us a positive, then x times x. So we just went from this nice little compact thing, we just sort of spread it all out into c squared minus cx minus cx plus x. We sort of spread it out into what it would actually multiply to. Negative cx and negative cx, so these are the same thing. So I'm going to combine those into one. Just to make it a little bit nicer for us. That's plus c squared minus 2cx plus. Tracking okay so far?
So many letters.
It is a lot. It is a lot. I understand. But hang with me. You're doing okay. You know what you're doing. We have all. We know what this. We've seen all this stuff before. It's just putting it all together. Now, because all this stuff is being added or subtracted together, we're allowed to rearrange it and move it around, and that's fine. So what I'm going to do is I'm going to take h squared over here. I'm going to move it to my back. And we'll see why we're doing this. It's just going to make it a little bit easier. So I have a squared equals c squared, which we have another part, getting closer, right? Minus 2cx plus x squared plus h. It doesn't really look much like what we want yet. We have this part, we have this part, and we have this part. But we still are missing those other letters.
Now we're gonna be.
We need b. So let's work with b. Let's try to get that. So b is right here on my triangle. What type of my triangle? No, hypotenuse one's here. How do we get a hypotenuse? Or how do we get a here? That was a hypotenuse, right? We use Pythagorean theorem. So using Pythagorean theorem once again, b is just the same thing, or b squared is the same as x squared plus a squared. Your hypotenuse is always those two other legs squared. Which, we have that, x squared plus a squared. This same one here. And that's why we moved h over, just to be able to recognize it right there. So we can So this thing is all the same as b squared. So that's a squared equals c squared minus 2 cx plus b squared. Just replacing, substituting in it. It's the same thing, so I can do that. So now we're getting even closer. We have c squared and b squared. The only thing we're missing from our original is that 2bc cosine of a. We need this one. What we have is 2cx. I need to turn that into 2bc cosine of a. So the biggest thing we're probably missing is that cosine. We need that cosine in there somewhere. The cosine of a. Looking back at our triangle, we need to figure out what is cosine of a. So thinking through SOHCAHTOA, the cub of our SOHCAHTOA, adjacent over hypotenuse. So looking at this angle, what is my adjacent side? X. What's my hypotenuse? So cosine of A is x over b. Once again, these are all numbers. We don't know what these numbers are. It's okay. It's just a lot of letters. The cosine of this angle equals x over b. Thing is, we don't have an x over b in our problem. We can't substitute that in. So we can't really bring cosine of a. But we have an x. So we can get this x by itself. We can then substitute cosine of a in for that. how can we get x by itself on this equation? How can we get rid of that divide by b? Multiply by it. So I'm gonna multiply by b. Cancel that out. But if I do it to one side, I can do it the other side. B cosine of a is the same as x. Once again, just like what we did with that x squared plus a squared, if it's in here, and the same is over here, we can substitute them. I can just replace it, because I know they're equal. So I'm just going to change this x with b cosine of a. So I have a squared equals c squared minus 2c. That x is being replaced with b cosine of a plus b squared. And if we look at this, and if we look at what we wanted, we have all the right pieces. They're just in a little different order, which is fine. We can just rearrange it to put it in the order. Because all this stuff is being added together or multiplied together. We can rearrange it, no problem. Doesn't bother us. So a squared equals b squared, just moving that to the front, plus c squared, which we have up here, minus 2. I'm going to switch this b and the c around, that doesn't change anything. Cosine of. We did it, guys. Starting with that little triangle, you ended up with that whole equation. You just proved the law of cosines. It's a lot. It's a big step. Luckily, though, now that it's proven, you don't have to do it again. It's proven, it's true, it's done. We solidified it. It is set in stone. Law of cosines is true. Yes.
Did any other geometry class have to do this, like, not in this school, but like other schools, like, we really have to prove it?
Yes.
Like, why? But we know it's true.
Yeah, 1,000 other people already did it.
I know. It's just making you more of a mathematician.
Or they're just you trying to teach it.
So are just trying to teach us how to do
No. When I was in geometry, I also had to prove it. So part of one of the standards in geometry is learning to prove and just learning the method of proving. Whether that's proving law of cosines, whether that's proving two triangles are similar to each other. So some of the stuff we did was like the two-column proofs, where we're proving two triangles working, or proving these two lines are parallel to each other, or proving these two angles are the same. So those are some of the easier things. But one of your standards also in geometry is being able to prove different theorems that we talked about. So I don't know, what are some other things we proved? We proved the Pythagorean theorem. We've proven Pythagorean theorem was a long time. I'm blanking on some of this stuff. We've proven a lot of stuff. Exterior angle theorem, we've proven that. We've proven we talked about conditional probability. I think we proved the addition of probability. So probability of A plus probability of B is probability of A or B is the same as probability of A plus probability of B minus probability of A or B. So yeah, we've proven a lot of stuff. So we talked about a lot of stuff. But yes, it is a standard in geometry to learn how to prove. That makes you a better mathematician and makes you better. Because when actual mathematicians, if you were to become a mathematician in real life, if I want to get my PhD, before I can be given a PhD, I have to prove something that's never been proven before. You have to discover something new in mathematics to be able to actually become a mathematician, like a full doctorate mathematician. And so like geometry, they're just setting up those levels. And then when you get into future math classes, you'll have to prove things. Calculus, you have to prove things.
Are you a master's or bachelor's? Is that the first one?
So I do not.
Right, going back.
Okay.
Ooh. A lot.
That's, one, I get a better salary if I get a master's. Two, I know
Here?
everywhere. So we'll take a break. Take a quick mind break. We just proven that. When we come back, we'll actually talk about it. All right, coming back from our commercial break. We just proved law of sines. Now we want to show it. We want to use it. So this is what we're actually going to be tested on. This is what you're actually going to need to know. How can you use law of cosines to solve for missing sides of right triangle? Or not right triangle, missing sides of any kind of triangle. But once again, just like law of sines, it's not restricted to right triangles. We can use it for acute, obtuse, equilateral, whatever type of triangle. The nice thing about law of cosines is it's really just plugging and chugging. So figuring out what are those variables, chugging it into the calculator, hitting enter, and then you're good. Why not use that phrase before plug and chug? So when you get a formula, you plug in the value, chug it into the calculator, and you're good to go. Plug and chug. All right. Just one. All right, so we have to figure out what each of these variables represent, and then we're good to go. A squared on the left side is always going to be what you're solving for. So in this case, we're looking for the side AC, like x. So that's going to be x squared. What was that?
Why?
A will always be the side you're solving for. Every time.
Okay. A will do what?
The part you're solving for. That's going to be your missing side of your triangle. It should always be a missing side of a triangle. That's always what you're looking for.
So we plug into
So the beginning of your equation should almost always be x squared, or whatever variable you're given squared. B and C are your other two sides of your triangle. So in this case, we have 10 and 22. It doesn't matter which one's B. It doesn't matter which one's C. It's just going to be the other two. So I'm going to say this is 10 squared plus 22 squared. Plugging into my formula. Minus 2 times, once again, it's B. So B was 10 times C, which is 22. Times the cosine. Okay. That's the last piece I need. A is always going to be the angle opposite of what you're missing. So right now we're missing that side AC. The angle opposite of that is B, which is 44. So 44 is going to be my missing angle. So once again, really you only need 3 pieces of information. You need those 2 other sides of your triangle, and you need that angle in between them. As long as you have that piece of information, put it into your formula, enter that thing in the calculator, and then you pretty much go. It's only 2 steps. We have x squared equals 10 squared plus 22 squared minus 2 times 10 times 22 times cosine 44. Setting it up is the hardest part. Once you have this done, you're good to go. Because from there, I can just grab my handy dandy calculator and type in 10 squared minus 22 squared minus 22 or minus 2 times 10 times 22 times cosine of 44. Type that whole thing in the calculator, hit enter, and it should spit out an answer for us, which in this case is 267.64.
And you can square root it.
Bingo. Just get x squared. That's our last step. Take the square root of that number, it spits out, and we are left with 16.636. That is current.
Yeah, that's
Nope. It looks really scary, but that formula is going to be given to you. So you just need to know, what does A squared represent? What is B squared? What is C? What is that cosine of A? What are each of those pieces? And if you know what each of those pieces should be from your problem, then you're good to go. Just put in the formula. What was that? You can use it to find an angle, but you will not encounter situations like that.
Because I didn't know how you would go about that.
I can't show you an example of that.
Like, we don't have to know that.
Eventually, probably in calculus or algebra 2 or trigonometry, when you actually do this again, you'll probably have to do that. But for right now, for geometry, we're just using it to solve for missing sides of triangles. So, keeping it pretty simple. If you get an answer that's like 3,467, and your other side links, or phone number, yeah, and your other side links are like 10 and 12, then your answer is probably wrong. It's probably because you forgot to take the square root. So I think that's the most common mistake, if people just bring and take the square root at the end, because you're getting like, my answer is 3,000, but my other sides are 5 and 6. That's not right. And so just remember to take the square root at the end. So if you, also you might get a really small answer as well. So just take the square root. That's probably the mistake I think occurs most often. Or sometimes you might forget it to your 2 Think you want to try one on your own? So, using law of sines, you want to solve for m n. It's going to be this side up here. So write an x up there for you.
Are you gonna write the business?
Yes. So your equation is a squared equals b squared plus c squared minus 2bc cosine of a. So figure out what each of those letters represent. Grab a calculator, plug and chug, find your x.
I'm gonna spell that.
So plug in your information. A squared, once again, that's your missing side, that's your x. X squared. B squared and C squared. B and C represent your other two sides that you're given, so that's 48 and 29. Once again, it doesn't matter what order 48 and 29 come in. So if you had 29 squared plus 48 squared or 48 plus 29 squared, it makes no difference. Minus 2 times B times C. So that's once again your B and C for those 48 and 29. 2 times 48 times 29. Because those are your other sides. And then lastly, cosine of A. And remember that capital A is always the angle opposite of what you're solving for. So if you're solving for an N, opposite of that is L, which is 1. Plug this whole thing into the calculator, let it do the work for us, and we get 3,818.53 or something like that. And then from there, we just have to take the square root of x squared for 3,818. This just leaves us with x because square and square cancel out. And then we get 61.79. Right around there should be our quotient for the calculator. Yeah. And that is law of cosines. Tomorrow we'll continue to practice a little bit more, and we'll also practice law of sines. And then Friday will be our SSR. Once again, this will be given to you, and law of sines will be given to you. You just take it back.